My dear students, I am going to teach you the third part of the chapter 5th, ninth class, Introduction to the Euclid Geometry. I have taught you first and second part. Both the parts were very important or are very important. I think you have read these two parts very carefully. Now I am going to teach you the third part. In third part, Euclid defined his postulates, and I will try to define these postulates with the help of examples, as I have given examples in axioms. So first of all, introduction to the axioms which I have taught to you. Some explanation of the part second. These are the explanation of the part second, because in part second time was less. These one two things I have not explained. So some explanation of the part second. Axioms. The explanation of the axioms like this. You can take help of this example. Area of a triangle is equal to area of a rectangle, and area of rectangle is equal to area of square. This implies that area of a triangle is equal to area of square. From first and second, this is the first and this is the second. From first and second, you can say from first and second. Now one thing I want to tell you, magnitude of the same kind can be compared and added. Same kind magnitude can be compared and added. And magnitude of different kinds cannot be compared and added. Same kind magnitude can be compared and added, and different kind of magnitudes cannot be compared and added. For example, these are the examples. Example, a line cannot be compared to a rectangle. This is an example. Line cannot be compared to a rectangle, and an angle cannot be compared to a pentagon, because these are, the line is different, rectangle is different, and angle is different, and pentagon is different. These cannot be compared. Now come to the postulate of Euclid. There are 5 postulates of Euclid, and I will explain one by one with the help of the examples. Now, listen to me very carefully. First postulate. Here, first postulate. Straight line may be drawn from any one point to the any other point. A straight line may be drawn from one point to the another point. Here I want to explain, a line can be drawn with the help of the 2 points. You have already studied in previous classes. A line can be drawn. This is A point and this is B point. A line can be drawn with the help of these 2 points. So a line may be drawn from one point to the another. In other words, a line can be drawn with the help of the 2 points. For a line, there is a need of 2 points. 2 points are essentially for drawing a line. This is the first postulate. And in first postulate, from a single point, many lines can be drawn. One thing I want to add it here, a line can be drawn with the help of 2 points. If you join 2 points, you will get one line. From one point, many lines can be drawn. AB is a line, and this is a point, and this is a point. Here, from this point, many lines can be drawn as you like. These are the lines. From a single point, many lines can be drawn. Like this, another point here, you can see that there are so many lines can be drawn from these points. These points are C and D. There are 2 points on a line C and D. If you want to draw a straight line from C, and how many lines you can draw? You can draw infinite lines. As well as C is also a point. You want to draw lines from point C, you can draw infinite lines. From 2 points, you can draw a single line. From a single point, you can draw infinite lines. This is the first postulate of Euclid. Second postulate. Second postulate. A terminated line can be produced infinitely. A terminated line. A terminated line. A terminated line can be produced infinitely. A terminated line can be produced infinitely. Here, I want to make this concept clear from a line. This is a line. AB is a line. This is a line. And definition of line. This line can be extended infinitely on both the sides. A line can be extended on both the sides infinitely. These are the sign of this extension. If this is a line and there are 2 points C and D, and we cut this line from at point C and D, this C and D, what is C and D? This is a line segment. C and D is a line segment. This is a line segment. And Euclid said this line segment or Euclid said terminated line. Terminated line. He said terminated line. Either you call it as a line segment, or you can say terminated line in the words of the Euclid. So this line, he said, this terminated line can also be extended infinitely. How? This is CD, C and D, and it can be terminated. It can be extended. This is a line segment, or this is a terminated line, and this line segment or terminated line can be extended infinitely on both the sides. This is the second postulate. This is the second postulate of Euclid. Now come to the third postulate. Third postulate. What is third postulate? A circle can be drawn. Third, a circle can be drawn. A circle can be drawn. A circle can be drawn with any center and any radius. With any center. With any center and with any radius. With any radius. So he said a circle can be drawn with any center, with any radius, and you can draw as many circles as you like. This is the circle. This is the center O1 and radius R1, one circle. This is another circle whose center is O2 and radius is R2. This is another circle whose center is O3 and radius is R3. This is another circle. And more example, this is the fourth circle whose center is O4 and radius is R4. These are all circles, first, second, third, and fourth. I have given four examples. This circle contains O1 and center O1, radius R1. Here, center O2, radius R2. Center O3, radius R3, O4. All the circles are different. So he said, with the different radius and with the different center, you can draw circles as you like, as many as you like. This is the third postulate of Euclid. Now, fourth, come to the fourth postulate. Fourth postulate. Fourth postulate. What is fourth postulate? All the right angles are equal to one another. All the right angles. All the right angles. Right angles. All the right angles are equal to one another. And what is a right angle? A angle of 90 degrees called right angle. A right angle definition. A right angle. A right angle is equal to 90 degree. This is the definition of right angle. And just like a circle, a right angle may be small, big, more big, but the magnitude or amount or a scale will be the same. This is the first right angle, 90 degree. This is the second right angle, 90 degree. This is the third right angle, which is 90 degree. And one more form, this is also right angle, 90 degree and 90 degree. This is the fourth form, first form, second form, third form, and fourth and fifth. Two lines intersect each other. Vertically opposite angles are 90 degree, 90 degree, 90 degree, 90 degree, 90 degree, AB and CD. These two lines, these are also 90 degree angles. These are the angles. See, so these are the examples of 90 degree. Example, 90 degree may be like this, 90 degree may be like this, 90 degree may be like this, and 90 degree may be like this. But all the 90 degrees are equal. This was the fourth postulate of Euclid, geometry. Now this was the fourth postulate. Now, fifth postulate. Fifth postulate. What is fifth postulate? Very important postulate, fifth postulate. You have already studied about the transversal line and parallel lines. If there are two lines, AB and CD, if there are two lines, AB and CD, this is the first case. This AB parallel to CD, AB parallel to CD. These two lines are parallel, and a third line, EF, third line, EF, third transversal line bisect these two lines, making the angle 1, 2, 3 and 4. Here, angle 1 plus 2 is equal to 180 degree. Angle 3 plus angle 4 is equal to 180 degree, because both the lines are parallel. So angle of the same side, sum of the interior angle of the same side is equal to 180 degree and 180 degree. If you produce these two lines on any side, if you produce these line on right side, these line will never meet. If you produce these line in left side, these line will never meet, because the sum of the interior angle is 180 degree on both the sides. But here, second example. Here, second example. AB and CD. These two lines are not parallel, and EF is any transversal line bisect these lines. And here angle 1, this is angle 2, this is angle 3 and this is angle 4. Here angle 1 plus 2 is less than 180 degree, and here angle 3 plus 4 is greater than 180 degree. Euclid said in this postulate, if these two lines are extended on right side, these two lines will not meet anywhere. If you, where the angle is less than 180, where the sum of these two interior angle is less than 80, if you produce these line in left side, these line will meet. These line will meet definitely at point Z. This is the fifth postulate. If in sum of the interior angle of one same side greater than degree, on that side line will never meet. Where the sum of the interior angle is less than 180 degree, and if you produce line on that side, these lines will certainly meet at any point. This is the fifth postulate of Euclid's geometry, defined by Euclid. So, my dear students, I have defined all the 5 postulates with the help of examples. I think the concept is clear to you, and if you revise this, all the 3 parts of this chapter, you will get a good knowledge of Euclid geometry, and all the postulate and axioms of Euclid will be clear to you. So in the last, I want to make a request to you. Please subscribe and like the channel. I shall be very thankful to you.